May 26th, 2012, 8:07 p.m. The subject is female. And I'm just fascinated with what she's doing with her hands here. Never seen anything quite like it in this species, and to be honest, I have no idea what the function is. Sometimes it almost looks as if she's measuring something, which I suppose is possible given the species is territorial, and perhaps that's how they measure their territory. The possibility, I suppose, is she's sensing some vibrations in the ground. Can't feel anything, but it's likely much more sensitive than I am. Well, now she's just looking in my direction, and the motions are getting very much more agitated. But not disturbing her, using up her energy, but now I understand why. It's another animal, and apparently a dominant one. This is very much like a dominance display of some sort. Very beautiful, but a lot of tension in here. Both using their hands now to apparently to communicate. Maintaining a distance. I think it's dominance. I know it's dominance, all right. But I'm just not sure yet about those hand motions. I wish I could feel what they feel when they do that. Maybe if I sort of emulated it a little bit.
you guys are going to do a scientific experiment using the dancers to manipulating these dancers to see if you can test for the capacity for humans to respond or detect an approach from behind.
And we're serious about that.
We're serious about that.
I want to look at the effect of timing of the start of the predator, the pace of the predator.
So you're asking, how does the timing of the start affect the detection by the prey of the predator?
You get attacked every time, but you don't know when the attack is going to start.
I would first ask, what's the frequency by which the prey can detect a predator without seeing or hearing them? And then what are the mechanisms?
Okay, trial begins.
Wakongolo tandala chaberedde wazinga enkata nga tannalaba kyakwetika. Wakongolo tandala chaberedde wazinga enkata nga tannalaba kyakwetika. Uyo mulaba mutandala chaberedde yezinze wazinga enkata nga tannalaba kyakwetika. Talina mutawana tandala chaberedde wazinga enkata nga tannalaba kyakwetika. Wakongolo oyo tandala wakongolo oyo tandala wakongolo oyo tandala wakongolo oyo.
Next time? Sure. Okay. Experiment 1, testing perception, trial 1, begin. And trial 3.4 meters. Okay, let's go again. Subject A, trial 2, begin. And trial. So 6.0 meters. Can you guys Subject B, trial 1, begin. And trial. So 5.5 meters. Subject B, trial 2, begin. And trial. There's our control. Okay, let's go again.
Yeah.
Subject B, trial 3, begin.
Barb, stop manipulating me.
You know what? I think I'm done. I think I've got what I was looking for today anyways.
Okay.
Move on?
Sure.
Okay.
Okay, experiment 2. Okay. Move sideways. Hands on head. Reach fingers. Look up. Peeling. Move sideways. Hands on head. Reach fingers. Look up. Peeling. Hands on head. Peeling. Moving sideways. Reaching fingers. Looking up. Hand on head.
Hey, do you think we did every single combination?
No, not even close. I mean, we didn't even manipulate size or speed or anything, let alone all the directions. Yeah, but let's move on. Let's leave that for another day.
Hey, let's move the tape line. Okay, let's divide the room in half.
Yeah.
From front Sit back.
I had that idea.
Okay. I think we should start with carrying the subject.
Okay,
Just go
right
like that.
over there.
No, wait a second. This person is the subject. Right here. We're testing their perception.
Seriously? No. This person's the subject, and that person's the object. Because the subject needs an object of desire.
Yeah, but we're not testing desire, we're testing perception.
Hey, I detect some subjectivity in that object.
Although, isn't everything we do subjective?
Then there's that question of ESP.
I've thought about that from the very beginning.
Okay, so we know we have a subject and an object, and somebody who's witnessing the interactions between the subject and the object. Now, there seems to be some subjectivity about who is the subject and who's the object. And perhaps there's like some perception subjectivity if you're a subject or object or witness, which means that the objectiveness of the witness could be perhaps like perceived as subjective? Is that right? Breathing. Touching. Sitting. Breathing.
This is not working for me.
Yeah. Lost total track of both of you.
Man, I lost perception of what I was even doing. Oh.
Yeah.
Let's go back. Let's go back a bit to the line.
Where am I? When I was a young scientist, I was intrigued by a simple scientific question. And that was, how does a prey animal, when it detects a predator, or what may be a predator moving towards it, make the decision about when to flee? It's actually kind of a crucial decision for the animal, because if it flees too soon, it may waste time and energy reacting to things which are not really of danger at all. And if it reacts too late, it may end up risking its own life. So it needs some sort of a rule in order to make that decision in an appropriate fashion. And I discovered a very simple rule in the little fish that I worked on, that can be represented in this graph here on the left. And the basic idea is that when an object is a long way away, great distance, and it moves towards you, the stimulus that it's presenting changes only a little bit with distance. But as it gets closer and closer towards you, the rate of change of that stimulus increases very rapidly. And at some point, that rate crosses a threshold. And that defines the reactive distance, RD, the point where the prey says, I'm out of here. Now, that rule actually has a lot of generality. It turns out that it applies to a lot of different species. It applies to other senses other than just vision. It applies, for example, to hearing. The basic idea is that it's not the size of a stimulus which we find frightening, it's the rate at which it's changing. Now, at an early point in our collaboration between scientists and dancers, the dancers asked an interesting question. They said, well, what would happen if the object was approaching from behind? Let's study that. And I was very resistant to this idea because it kind of smacked of extrasensory perception, or ESP. And that's a place that a scientist doesn't really want to go if they don't want to lose credibility with their colleagues. So I was not too keen on this, but the dancers went ahead and did it anyway. And you can see some of the results of their experiments here tonight. And as I saw these data coming in, I began to get more and more interested in it, and I got re-engaged as a scientist, because clearly there was something interesting going on. There certainly seemed to be some situations, at least, where the dancers were able to detect someone moving from behind them. What sense they're using, we're not certain. It isn't vision, because unlike your mother, they don't have eyes in the back of their head. But something is allowing them to detect this object behind them. And experimentally, we could determine what that was. It's not a sense that we are used to, and so in a way, it's extrasensory perception, but all that means is a sense we haven't studied. But what's exciting about this is it's an anomaly. It doesn't fit into our neat little box of theories and laws the way we understand sensory perception. And that means that that's where science really happens, where those anomalies occur. And you can actually think about it in the same way as this graph, that when there's a few anomalies occurring, it doesn't upset us too much. But eventually, the rate at which those anomalies accumulates gets to a point where we reach a threshold and we have to break our existing paradigm and come up with a new one. That's a very uncomfortable place for a scientist to be. But it's also where all the excitement of science happens, because that's where we're expanding our knowledge and pushing back the boundaries of ignorance.